Hello guys, welcome back to my channel, Boy. This is another Simulkuy episode, and today I will be talking about crude compatibility analysis in UniSim design. And this is one of the utilities that we can use in simulation to determine the compatibility of a crude blends in a refinery or in an upstream operations. Okay, so let's go. Before moving to the simulation, I would like to explain a bit about the basic of crude compatibility analysis. And if we want to study crude compatibility analysis, we can start by understanding the SARA composition. So SARA is actually the abbreviation of saturates, aromatics, resin, and asphaltenes. So saturates is a non-polar fraction. It could be linear branch or cyclic saturated hydrocarbons, while aromatic is more polarizable, uh, and it contains one or more aromatic rings. Then resin, it is polar. It is miscible with heptane. And lastly, asphaltene, it is also polar, but it is not miscible with heptane, and it is heavier than resin. So you can see, even though SARA analysis also a bit similar with PNA analysis, but the goal of the SARA analysis is to measure the solubility. That's why we care a lot about the polarity of the components, which one is polar, which one is non-polar, and is it soluble or not. We need to think more on that side. After knowing the SARA compositions, we can calculate several stability parameters. The first one, we have colloidal instability index, or short as CII. It is the ratio between saturates plus asphaltenes to the aromatics plus resins. And if our result is bigger than 2, then it tend to be incompatible or unstable, and it will precipitate asphaltenes, which we doesn't want. Another parameters that we can calculate is A per R ratio, or aromatic per resin ratio. So the formula is exactly like the name says. We divide the aromatics by resins. And if our result is larger than 0.35, it will be very unstable. Another way to measure the instability or stability is by using the SBN-IN model. So this model is very useful to predict and prevent asphaltene precipitation while blending the crude oil or heavy oil. So there are two parameters that we need to evaluate. The first one is insolubility number, which is the degree of asphaltene insolubility, and solubility blending number, which is the ability of oil to dissolve asphaltenes. If we have several crude, we need to calculate the SBN mix by this formula. Then we need to compare the calculation result of SBN mix with the biggest IN. If our SBN mix is larger than the biggest IN, so it is called as compatible. After we understand the basic of crude compatibility assessment, let's go to the simulation. Here I have two streams. The first one is test and second one is test 2. This is an assay. So I'll go to the oil manager to show the assay. So this is the assay. You can use the similar one with me, or you can create your own assay. My goal is to have an assay with the FBP of 500 plus, because in this condition, there will be asphaltene fraction. We could make sure by going to the cut plans and then see this distribution plot. So you could see the gray area. This one is residue, and residue boiling point is between around 350 to 500. Okay, so in this blend, I have some residue. I have naphtha, kerosene, and etc. So I will go back to the simulation environment. This is the base composition from the oil manager. And test 2, I use the same assay, but I increase the fraction of heavy fraction, which is the residue. So you could see how it will differ. So you could see how it will differ in the SARA analysis. Next, we can create the utility by selecting the Crude Compatibility utility, click Add. Okay, then you can add both stream. Okay, next we could see the performance. So here you could see that the calculation has been done. We could see the Sarah analysis result, A per hour ratio, and also CII. And on the bottom side, it is the mixture between test and test 2 stream. So it will get this result. There is one button here, re-estimate Sarah for the crude band. What does this mean? I will show you in my Excel calculation. Okay, so I have copied the result, the simulation result here. So the above one is test, while the bottom one is test 2. This is the result from simulation. And if we don't click the free estimate Sarah for the crude blend, we get this result. So if we want to calculate manually the mixture between these two, this is how I done it by multiplying the Sarah with the flow rate divided by the total flow rate. Okay, so this one is D7, which is the set rates of tests times the flow rate of tests plus the set rates of test 2 times the flow rate of test 2 and then divided by the total flow. So I will get this number. However, let's see how if we take the re-estimate Sarah for the crude blend. If I check the re-estimate Sarah for the crude blend, you could see the calculation will give a different number. So how we can get this number? If we check the re-estimate Sarah for the crude blend, it is like we directly mix both stream into one stream. While if we don't check this option, it means we will linearly calculate from the composition of each Sarah. So we can use the formula that I use in Excel. However, if we want to calculate this manually, we need to directly mix the stream, this, and then it will be a mixed stream. Now we can try to add utility to the mix. Now you could see that the result is the same, yeah, between the output of mixer and also the result when we check the rate estimate Sarah for the crude bed. Actually, the difference is not far. So in this case, we don't really mind which option to use. The next thing, we can also see the SBN-IN compatibility. However, in this model, UniSim cannot calculate the SBN and IN. We need to input the number of SBN and IN. So we can just use it for practice here. For example, the SBN is 38, the test 2 is 34, and the IN is 20 and 15. Okay, so we could get this result. Let's copy to Excel. Okay, so this is the SPN IN for the individual. If you want to calculate the SPN mix, the way we do it is by multiplying the SPN with the flow. Yeah. And then we divide by the total flow. Okay, we will get the same result. For the max, it's very easy. We can just find the maximum IN from all the mixture. Since SBN mix is larger than IN max, so this crude is considered compatible. Okay, so that's all for this tutorial. I hope it will help you to understand about crude compatibility simulation in UniSim design, and see you in the next episode. Bye bye.